Hey, welcome back. Welcome back to the series. Now, if you remember, we had left by covering the fundamentals of ML. So, in the last session, we we completed with the challenges of ML. Now, we are going to take a look at the supervised techniques. That is the classification. So, the agenda for today's tutorial would be understanding the MNIST dataset, training a binary classifier, doing different performance measures, and just as a brief explanation, I will give you an idea of what are the different types of classification that there exists. So multi-class, multi-label, multi-output classification. All right, so let's get started. So in this, I opened up the Jupyter notebook. It is my paper space instance. Now, if you guys don't know how to set up a paper space instance, I will show that to you. Don't worry. However, I would recommend using Colab, but I'm just used to using Paperspace free, their GPU notebook, which I like it better, and I like their interface as well. So you guys can see what works best for you. But if you're just starting out, which you guys would be, I assume, then I would recommend using Google Colab. All right. Anyway, let's move on. Now, if you wanted to know how to set up an instance, um, you guys just Google um, paper space and you see this console. You click on that. So what these people do is basically they give you free GPU instance. Now it will ask you to sign in. You can use Google or your GitHub if you have one, and then you can create a project. And once you create a project, you can give whatever you want to name. I've given foundations to applications. You click on that. Now it will ask for the different. If you already have a notebook running, it will show that you have a notebook running. If not, then you would want to click on create, and then select. Since we are working with the TensorFlow runtime, click on TensorFlow. And do keep in mind that if you have already, in this instance, in this case, I'm already using. You can see that it is running here, right? So I'm already using their GPU instance. So if you're already using it, you won't get access to two GPUs simultaneously. So their free tier version, you see, uh, it says currently out of capacity for this machine type, right? So that's because I'm using their free GPU, which is 8 GB. So you just click on that, and I would prefer you click on 6 hours because you don't want it to, 1 hour is too less time, the auto shutdown. You select 6 hours and then click start notebook. It will take some time. That is the only drawback. Doesn't take too much time, but it does take some time to set up the first time. So you just wait it out, and then you shall have the notebook. So once you start the notebook, you'll be greeted with the Quick Start Beginner and Quick Start Advanced notebook. However, forget that we are running our own notebook. So that's how you start the Paperspace Jupyter Notebook instance with a free GPU. All right. So the first and foremost in today's tutorial is understanding the MNIST dataset. Let's get to it, shall we? All right. So let me just copy a bit of text here, and then if I hover here, it'll show at a markdown, right? So I'm just going to paste that. All right. So maybe I don't think you guys can see it. Let's make this a bit bigger. Yeah. So in this chapter, we'll be using MNIST dataset, which is a set of 70,000 small images of digits, handwritten by high school students and employees of US Consensus Bureau. So don't worry about that. Basically, this data set has 70,000 images of the dimension 28 by 28. It basically consists of digits from 0 to 9. Those are handwritten. So why are we talking about MNIST even? Now, if you come into, if you jump into the realm of machine learning or deep learning, you are more often than not going to have to be dealing with the MNIST data set, because it is so widely used, and it is like the hello world of machine learning data sets, so to speak. So yeah, so that's why we want to understand how this data looks and see what we can do with it. All right, so I'm just going to type some bit of code. So we're going to be using something called as sklearn. So from sklearn dot datasets, import fetch underscore open ML. And this OpenML consists of, let me just run that. Yeah, so that ran without an issue. We want it down. Oops. Yeah. So let me just add a bit code lines. Or you could also type A as a shortcut. So open, the sklearn.dataset gives us a function called as OpenML. Now, since MNIST is so widely used, we have different libraries that support this dataset out of the box itself. So you don't have to download it from anywhere. MNIST is equal to, if I say fetch OpenML, and then I want MNIST, course IST 784. Now I'll tell you what that 784 stands for. Then if you wanted, you could specify the version to be 1. So for reproducible purposes, just follow the same version, but you're free to explore. All right, so let's give that a second. So what this MNIST underscore 784 tells us is that we are looking for the data set MNIST of the dimension 784. Now do keep in mind, now 784, so it's 28 by 28 pixels, right? So 28 by 28 is equal to 784. I know why it's taking a little time. Yep, it did take some time to, I think it took some time to download the data set, as it was not there in the local instance. So it downloaded the data set, and we got the, if I type mnist.keys, it's basically a dictionary. This mnist, whatever we get, is a dictionary which contains target, data, target, frame, categories, feature names, target names, description, details, and the URL of the data set, right? So and if you type mnist.keys, it returns the different dictionary keys. Now, like I was saying, 28 by 28 or 28 into 28 is 784. So whatever we get in the data, right, will be a vector of 784. A vector of 784 is the dimension. It's a single array of 784 different values. However, when you are trying to use it, you need to reshape it to be 28 by 28 as x and y. Because that's how we can represent an image, right? Image cannot be a single dimension. It needs to have at least the x and y value, the height and width. That's what I mean. All right. So now we have that out of the way. Let's say x comma y is equal to, now since we have that MNIST, all right, what we could do is we can say data as x and target. If you see the keys here, it has the data, that is the x, that the independent variable, and the target, that is the dependent variable. So what you could do is you can easily do tuple unpacking, where x becomes or gets allotted to MNIST data, and y gets allotted to MNIST target. All right, let me just run that. It should be fairly quick. Now, if we take a look at x dot shape, like I said, it contains 70,000 images, right? And it has 784 the size is 784. And if we take a look at y dot shape, it has 70,000 labels. Makes sense, right? Now, since there are different 70,000 different samples, it should have 70,000 different labels. So this 70,000 consists of different digits from 0 to 9, and the label consists of the corresponding label. If the number or if the picture is 7, and the corresponding label will be 7. That's how it is working. Now, if we take a look, I mean, if we wanted to plot it, it's matplotlib dot by plot as plt. Right now, I can say some digit is equal to x of, since x is an array, of course, we can query it, and then, like I said, we need to reshape it. So some digit image would be the sum digit di, what the hell, digit dot reshape, right, and 28 comma 28. So that's how we wanted it to be reshaped, and plt dot imshow some digit image and maybe we can say color map to binary, so that it gives us the black and white. Now, all right. Now, in order to visualize the data set, what we have to do is, we set some digit x dot values. Now, to keep in mind that x is not just an array, it is a data frame, right? So the way we get uh, the data, the type of this data is a data frame. So in order to get the value, we have to say dot values of 0 or of whatever index, and then we reshape that, and then we can plot it. All right, so now the same thing. Now if we take a look at y, it is just a label. Right now, if we do type of y, just to know what type y is, it is a series. So now if we wanted to say y of 0, now we can index the series, but indexing the data frame, especially when we are dealing with numerical values, it's better we use the value attribute of the data frame and then index it. So the value attribute gives us an array. Now if we quickly take a look at it, right? So now if we say x dot values, it's basically an array. Now if you know take a look at the shape, it gives us 70,000 by 784. So now that we know this is the exact array that we are looking for, we can index the array and do plot or do whatever we wanted to do. All right. So now that we know that y is actually giving us the same answer as the digit or as the image, we can go ahead and confirm that they are in sync with each other, right? So now if you see, if you really observe, now y of 0 is not a number. Sorry, yeah, it's not a number, it's a string. So we all know that machine learning, machines cannot handle string data type, right? So they have to be converted to numerical data type. Not just machines, even different machine learning algorithms. Anything that you represent as a string needs to be converted into number. So what we could do is we can say y is equal to, so the entire y series, we can say as type of np dot unsigned int 8. My apologies, I should have imported numpy as np, and yeah. Now if you take a look at why it is going to return us number. See, there is no string, so there is no quotes on top of the number. So that's how we can confirm that it is actually indeed a number or integer type and not a string type. All right, now that we basically have the idea, let's go ahead and do the train test split. So x train, x test. So I'll quickly talk about this. Y train and Y test, right? So, oops, I put a dot, the Y test. So now what we want is we are splitting the entire array of X, which has 70,000 images, into train and testing. So the train data will be going to the machine learning algorithm or the machine learning model, where it takes that data to train the model, whereas the test data will be going to predict on how well the model is actually performing. So we want some kind of metrics, right? We want to be able to measure how good the model is actually doing, and only then we can make the model better, right? If we don't have some kind of performance measure or some kind of metric to quantitatively tell how good the model is, then we don't know whether we are whether the model is going towards the right direction or it is going somewhere else and not really doing what we want. So that is why we do this. So what we do is, now since x is an array, so what we can do is we say x dot values. So we want everything until 60,000 to be going to the train data, and x of, so x dot values of, now from 60,000 till everything we want it to go to the train data, sorry, the test data, right? The same thing for y as well. So y till everything up until 60,000 we need it for the y train, and from 60,000 till everything we want it for the test. Now if we quickly take a look at x train, right, and if we take a look at the shape of it, so we see that it is only till 60,000, and of course it is 784. Similarly with y train, it is 60,000, of course, the corresponding labels, and x test, it should be 10,000. Yeah, so since it is only consisting of 70,000, the MNIST data set only has 70,000 different images, and since we are already using 60,000 to train images to train and its corresponding label, we have only left out with how much? Just 10,000, right? So everything apart from 60,000 is going to the test. So we are splitting its 60,000 for training and 10,000 for testing. And if we say y, it is going to have the correct samples or the labels. All right, now that we have a clear understanding of that, let's go ahead and train a binary classifier. Now, why do I say a binary classifier? A binary classifier is because it is only going to do a binary classification, right? So whether if the given number is, let's say, if we wanted to ask whether it is 5, then it will say whether the given number is 5 or not 5. It is very binary, right? 0 or 1. So that's why we are saying a binary classifier. Now further down this tutorial, look at different types of classification that we've already discussed here. Types of classification. But right now, let's focus on what we are here to do. So now let's take an example. We'll say y train, oops, y train phi is equal to y train double equal to phi, and y test phi is equal to y test of double equal to phi. So now what this is doing is, now, for simplicity's sake, I'll just add a code above, and then if I say y train equal to 5, it will give me Boolean values where the number is 5 for y train. So let's take a look at it. You see that those places where y train has the value 5 is set to true, and those places where the y train has does not have a value 5 is set to false. That's how this works. So what I'm doing is, this is basically an array that returns at the output of this will be an array. So I'm just setting that to a variable. Oops, underscore phi. The same thing with y test as well. So if we take a look at y train underscore phi, so you see it's basically an array type which has Boolean values, true or false, and it will be set to true wherever the value is 5, and it is set to false wherever the value is not 5, right? So, and that is why we don't have many 5 values. You see, many of them are false. So that's why there are many false compared to trues. Now let's train a classifier using scikit-learn itself. So I put this above, right? And so we can say from sklearn dot linear model import sgd classifier. So sgd classifier is a different it's a kind of classifier that we can do some kind of binary classification on it. So now we say sgd. So there are different classifier algorithms that we can use. So one such right now that we are using is sgd. And then for reproducibility, you can just put random state to 42, and then we can say sgd classifier. CLF stands for classifier. Dot fit on the data, right? So we have the X train and the Y train. So now why am I not passing the Y train and instead I'm passing the Y train phi? Now, like I said, now whatever we are doing is a binary classifier. So the model needs to kind of understand why is the output true and why is the output false. Now it can become very very intuitive that for the image that contains phi, we have the output true, and for all the other instances or the image that does not have phi, we have the output false, right? So what will the binary classifier do later? Now if given a new image, we can just give the image of a 5, and then we can expect the model output to be true, right? And if we give some other value, it will be false. So that's what we are trying to do, and that's why it is called as a binary classification or binary classifier. So let's go ahead and do it. All right, now when we run that, we have the sgd classifier, we get the output. Now what we can do is we can start predicting now that the model has been fit to the data. So we can say sgd classifier dot the predict method, and we can pass in some array. right? And if you remember, we had the sum digit. So the sum digit basically consists of the first value, that which is the 5, right? So we can expect an array which outputs true, right? So if we, you know, if we predicted on some other, let's so x dot values of, let's say, 14, right? uh yeah, so it gives false, right? So if we take a look at the corresponding y value for it, I'll put this down. So the corresponding y value, so y of 14 is 1. So it's not a 5, the number is 1, and that's why we got the array as false. So I hope that makes sense. And now that we have trained a binary classifier, understood the MNIST data set, we have trained a very simple binary classifier with just 3 lines of code. Of course, did some pre-processing, not pre-processing, just split the values into x train, y train, x test, y test, and then we predicted it, and it is pretty good. So now the next what we will look into is performance measures, and then types of classification. So till then, take care.